All right, so in this video, I'm going to take you through the basics of exponential functions. This is where we'll start our unit while we're out of school. So exponential functions, unlike linear, they will have a repeating pattern of multiplication. Here you can see I'm multiplying by 2, multiply again by 2, keep multiplying by 2. That is always a dead giveaway of exponential functions. It can also be dividing by the same number. We call that the common ratio. So the cool thing and scary thing about exponentials is they grow really, really fast. Okay. Now, right now we are living in a time of kind of pandemic. We have the coronavirus going on. Okay. So if you can look here, you see a dramatic increase in the number of cases. This is exponential growth, and that's not what we want. So what they are actually trying to do is, with this isolation that we're encountering, we're trying to, instead of what it would be uncontrolled, we're trying to get this red one, which would be more safe for everybody, less numbers of cases. Okay, so reducing that rate at which it is spreading. So another cool example that I know that is out there is called a paper folding, and they actually have a pretty cool Mythbusters on this, where if you fold a piece of paper 43 times, it would reach the moon. Now, that sounds ridiculous, but mathematically it actually makes sense. You take a paper that is 0.05 millimeters thick, you fold it in half, it should double, 0.1. Then fold it in half, it becomes 0.2, and so on. And you can see, I'm just going to jump right here. This is how thick in millimeters that would be, which is 439,000 kilometers. Okay. And on average, the moon is only 384,000 kilometers from Earth. So it sounds crazy, but it actually would happen if you could fold a piece of paper 43. Now I'm saying the word if. All right. So the actual work that y'all have to do at home. Exponential growth, we'll use this formula. Okay. Exponential decay, we'll use this formula. So growth means it will increase. Decay means it will decrease. Adding for growth, subtracting for decrease. So whatever you have, though, when they give you a percent of growth or percent of decay, you have to convert it to a decimal, which is done by either moving the decimal 2 times to the left or dividing by 100. So those are a couple examples. All right, so here's your first problem off your guided notes page. You have 1,440 employees at a company, and that number is increasing 1.5% every year. This would clearly be a growth, so you would use this formula here. Okay. The value of A is always how many you start with. The value of R is your rate of increase or decrease converted to a decimal. So 1.5% as a decimal is 0.015. You take that 1.5, divide by 100. So here's your formula. 1440 multiplied by 1 plus that rate of increase to the x power. Okay, and that x represents an amount of time. So here is your formula. If we actually add the 1 and the 0.015, you get 1.015. Either one of these is acceptable. All right, so a second example. The deer population is decreasing by 2%, and you started with 1850. So this would be an example of decay. You would use the formula based off of that. And here would be your values. 1850 is your original. Your rate of decrease is 2%. So when you plug these things into the formula, 1 minus 0.02, you should actually get a base of 0.98. So either one of those is acceptable. So just a couple more examples. These aren't actually on your papers, but they'll help you get some of the other problems done. In 1985, you had 285 cell phone subscribers, and it increased by 75% per year. So those are important values. You would want to use the growth formula since it's increasing. 285 is your original, 75% is 0.75. That would be your formula. You could rewrite it 1.75 if you like. And if we're going to answer the question, how many subscribers would they have in 1994? Well, that would be 9 years after. So we want to put in a 9 as our exponent, fill that in. That's how many subscribers. Okay, just use a calculator. All right, our last example, you have bacteria that are doubling. You started with 1 bacteria and they double every hour. How many by the end of the day? Well, you start off not by using the growth formula. Double means by 2. So you had 1, you double, you do that every single hour for an entire day. That would be this, which is a